to do it last year. Good, we'll talk about that later. You're not going to do that the first few times because it's important to understand what a derivative is and where it comes from and why later on when we say the limit definition. Part 2, the limit returns. I don't know. Now, here's the game. Everything we do with limits is based, with derivatives is based on limits. So later on we're going to learn some derivative rules. They're just limit laws. No thanks, I'm just watching you because it's nice, it's fun. That's something else you can add to your resume list. I can open a starburst. That's awesome. Dude, you are just all kind of talented. Now, so that's kind of a big deal. And then also, what do we get when we get these things? So here's the game, okay? So we're going to be discussing, hey Garth, your sister's here. It's exciting. That's exciting. Thank you. There we go. Now, suppose I have a function that looks like so. Now, notice I'm drawing a continuous function. It's nice, and it's continuous. Yes? Nice. I'm going to come over here somewhere. X. What is this point right here on the graph? What is the coordinates of that point, Lily, if this is f of x? Well, I'm going to write f of x down here. This is the graph f of x. What would the coordinates of this point be? Don't overthink it, crackhead. There's no numbers, so you can't get that part wrong. What's the x coordinate of it? Okay. And what's the y coordinate of it, huh? It is. You're a genius. Well done. Now, Brooke, I'm going to go over this way just to skosh. You with me? I'm going to go over about h units over, okay? Where will I be now on the x-axis, dear? I know! And up here, there will be a point on the graph, correct, dear? And what will that point be? X, comma, y-ish. What would it look like here? Yes. 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 That's amazing. Now, Lily, back in Algebra 1, which was, for you people, I don't know, 5th grade. What, who knows? For me, it was freshman year of high school. But whatever. I was stupid. We didn't have that kind of crap back in the day. Now, here we go. Could you find the equation? Could you find the slope of that line, Lily? Would that be possible for you? How would you find it, dear? So m equals literally couldn't have done it better myself. Couldn't have. Do you notice anything else about that equation that you just wrote up there, dear? I feel like those guys cancel out, don't they? Huh? As a matter of fact, when you did this, did you not, in your mind, go, now Mr. So-and-so told us it's rise over run, Mr. Groom. Didn't they say that? I spell it that way on purpose. That's how you know the Y's go on top. My first year of teaching high school, I thought this would cure all my Algebra 1 idiots from doing it wrong. Do you know what? It didn't. They still spelled it like this, and they still put the X's on top. Pathetic. Now, wait a minute, Mr. Groom. That's not what so-and-so said. So-and-so said it's the change in Y over the change in X. And somebody else says, no, you're wrong. It's Y2 minus Y1 over X2 minus X1. And someone else goes, yeah, well, my teacher showed us this cool thing. Oops. I know, it's all the same. How far apart are my X's? H. What is the difference between them? It's H. That's it. Now, this thing right here, this guy right here, delta. This just, whenever you see delta, just means change. In. So when delta y over delta x, that's kind of a big deal. Huh? Now, question, coming back to this graph, if I started here and I finished here, and this was something like, and my y's were something like displacement and time, and you went, I started here and I finished here, Mr. Groom, and I found me a rate. What would you call that rate? Would you call it an average rate? I feel like it would be, yes? Because on average, you went this far in this amount of time, correct? Well, today, friends, this is the last time. Say goodbye to your mathematical innocence. Never again, almost never again, almost never again will we ever talk about an average rate of change. No, sirree, Bob. From now on, we're into the magical, wonderful world of calculus. From now on, everything will be instantaneous rates of change. How fast are you going right now? I don't know. I need to know. So here's the game. We're going to take this thing right here, that thing right there, and we're going to take the limit of that thing as h approaches 0. In other words, I am going to let those 2 points on the line, I'm going to let them get closer and closer and closer together. Okay? Okay? So look at this right here. Suppose this point, suppose it was h got smaller, and so now the points were like right here and right here. This would still be this guy right here, yes? It just have a smaller h. And now the line would look like this, would it not? Hey, that looks more like what the graph's actually doing, doesn't it? Hey, let's get a little closer yet. Dude, that's awesome. Question though, I feel like the limit has to exist coming at it from both sides, yes? So is there any reason why h couldn't have been on this side? No. H could have been on this side to start with, you see? And then it gotten closer coming this way. That's a big deal because later on we're going to talk about functions being differentiable. That is, you can take the derivative of them. And it's going to matter because some functions are not differentiable at certain values. For instance, here is the square root of x. Wow! Notice how it just burst onto the scene right here? Okay? It's just, wow, now I'm here. Obviously, I could put a point here at 0, 0, yes? I could put another point over here somewhere like so. No problem going that way. Can you get on the other side of 0 if it's the square root of x? No. So it's not, we say, differentiable at 0. It doesn't have a derivative at 0 on that guy. It doesn't exist. Because listen, in order for it to have happened, it had to have changed from somewhere to here. What did you have a minute ago? Well, I don't know, Mr. Groom, but now I got 0. How fast did it take you to get there? It was instantaneous. That's a problem. Okay? That's going to be a problem. Now, also later on, here's our good friend, absolute value of x, yes? We like him. He's a swell dude. If you put the point at 0 and put one h on this side, the slope on this side is positive, isn't it? What is the slope on this side? Negative. Wait a minute. You can't have two different limits, can you? Don't the limits have to be the same, right? So the left-hand limit has to equal the right-hand limit for the limit to exist. And so because the left-hand limit doesn't equal the right-hand limit, the limit doesn't exist. What are you saying? I'm saying the derivative doesn't exist right there. And so later on, we get into this more in depth. It's going to matter that this is a limit. When I was a kid, they said, it's not differentiable there. Okay, why? Because there's a point. Oh, okay. But why? Never mind. It's not important. But it is important. It's hugely important. But it comes because it's a limit. So that it has to be the same no matter on what side of h you put it on. It has to be the same. So in the case of this one, it had positive slopes, negatives. I don't care what they are. Positives are never equal to negatives. It's not going to happen. Now, in the case of this fella, which is nice and smooth, as you put a point here and a point here, and they get closer and closer, this is approaching a 0 slope, isn't it, coming down, right? If it was right flat across the bottom, it'd just be a 0 slope, wouldn't it? That'd be the same thing on this side. It started off negative, yes, but the closer they get, it approaches a 0 slope. That's nice. This is how I like, by the way, I like my braking to look like this. Oh, nice and smooth stop. I would prefer my braking did not look like this. Wham! Yeah, no, that's bad. I want my braking to be nice and mellow. Even if it's a little more like this. Oops, not like that. Even if it's a little more like this. But as long as it's smooth. Please make sure the calculators get back in the box when you're done. Thank you. I am really getting tired of my calculators ending up all over creation. It drives me bananas. Now, well, we need a function. So, because this is what always happens, we're going to pick our good friend x squared. Okay? Now, the recipe that we were told is that we were to take the limit as h goes to 0 of f of x plus h minus f of x over h. That's what we're told to do. Well, listen, I've got f of x. You know what I ain't got? I ain't got an f of x plus h. So what would it be, f of x plus h? Feel like, Jacob, it would be x plus h squared. U.
Okay.
Yeah. Which one is he looking at? I can't tell. Yeah. Yeah. Don't look up and make eye contact. Pretend like it was the other one he was talking to.
There's that one, there's that one, there's that one. You could be talking about Donovan.
So you add the 24 on the outside, so then it's...
I never realized that. 1, 2, 3, 4, 5.
4.5. Donovan's...
Oh, 4.5. That's 4.5. But that was like my kindergarten class. There was 5 Johns, including me, in a kindergarten class in a small town with, what, 25 kids maybe in a kindergarten class? That's why I went with Jay instead of John. That's weird. 5 Johns, my small little town. That's weird. It's odd. 4.5 Jacobs. 4.5 Jacobs. I got 2 Lacey's in class this year. It's weird. What's up?
So you add the 24 on the outside, so then you have the 3D and you subtract that.
Yeah. Yeah. Good.
The systems look like this. 6A plus 6B.
Yeah. So what could you put in for A and B to get them to cancel out?
And the opposite.
Literally, but I would use...
One and eight.
That's what I would do. But you're certainly welcome to use 14 and...
This one has negative 3 plus 6B.
But so 1 and 1 wouldn't work, right? But what do they both go into? Well, they both go into 12. They both go into 24. Right? To cancel out to 0, right?
Yes,
They both
these
go
ones plug in front of C2, and this one plugs in front of C1, correct? I've been mixing that up.
Yeah.
The same.
Okay, so, are we good here? So, the thing we're going to do, Connor, is we're going to distribute this out. So it's been some time that you've done this. So of course this is x squared plus 2xh plus h squared, correct? That's a pretty common thing that people screw up. They will forget this middle term. Most of course screws up your whole answer. Don't be that person. So here we go. We take the limit as h goes to 0. X squared plus 2xh plus h squared minus x squared, the original function, all over h. All I'm doing is following a recipe here, friends. That's it. That's all. What do you notice that happens on the top?
The x squareds cancel.
The x squareds cancel out. But listen, friends, this is a big freaking deal. Look at this. Look at that. That is your original function. Your original function, if you do it right, will always subtract out. Always, always. Always, always. If it doesn't, you screwed up. You should stop and fix it if you screw up at such a time. Don't keep going and then go, oh, it's the wrong answer. No, ding dong. If the original equation does not cancel out when you subtract, you screwed up. And so notice you're left with this. Here's another oh by the by. If everybody on top does not have an h in it, you screwed up. Okay? That's because everything that just had an x in it, that was the original equation, will have subtracted out. Everything that's left will have an h in it. Which is good, because what's the next step? What do you notice on top, friends? Everybody's got an h. Dude, let's lose them. And I am left with the limit as h goes to a goose egg of 2x plus h. What happens as h goes to 0 here, friends? What are you left with? 2x. Ta-da! And and by the way, we call this the derivative. And we will write the derivative several ways. Notice that originally we were given f of x is equal to this. We will write our derivative as f prime of x is 2x. Now notice we put the prime on there to differentiate between the original function and its derivative. We call it f prime because it's the derivative of f. Nice. Nice. Question comes to mind. Mr. Groom, I saw in a book one time, or wait a minute, Mr. Groom, let me back up a train. Mr. Groom, what if the problem is written y equals x squared? Then we will write y prime equals 2x. But one time, I was watching a TV show, and they mentioned a guy named Leibniz. That's correct. This was Newton's method of writing it. I dig it most of the time, y prime, f prime. But the fellow by the name of Leibniz, his notation was this: dy dx equals 2x. This actually is very handy and very wonderful when you're doing differential equations. Other places, there's a few places, and we'll use it in calculus class. You can always use it as in terms of, you can always write it like that. It's just not terribly helpful sometimes. Are you spitting it back in because it tasted so nasty?
No, it's like spilling as I'm trying to get a drink. Where?
It was just really funny in terms of, it just like you took a drink and it was just the most heinous thing. And you're wondering if you're going to spit it back into the jar or not, which has been really funny. I would have laughed. Your boyfriend rating would have probably gone down if you'd done that, though. So either way you write it, but listen, for most of the time, I'm going to write it like this for most things. I find it easier and more appropriate. Obviously, if it's written y equals, then write y prime instead. But notice, why the dy dx? Wait a minute. Didn't we start off with delta y over delta x? Notice that these are what we call macro-sized changes. Oh, but when we take the limit, we're making it so that they're very micro-sized, yes? These are what we say, if you will, infinitesimally small changes. And I don't care if you remember the infinitesimal part, but small changes. You see that? Because they're very, very small changes. So we reduce this delta y over delta x to more of a dy dx. Look. Okay? So remember, this function started out to be our good friend y equals x squared. You see that right there? The slopes on this side are what? Positive or negative over here? Well, Mr. Grimm, it's curved. It doesn't really have slopes. But it does have, you could draw a tangent line, oops, to it, couldn't you? And then here you could draw another tangent line, and of course it would be flatter, of course. And on this side you could draw tangent lines as well. Something like this, yes? And the slopes of these tangent lines are the derivative. But Mr. Groom, it matters where you are on the x-axis. Well, duh. F prime of x, the slope, you see, is a function of where you are. How about that? It's equal to 2x. So when I'm over here at x equals 1, 2, 3, 4, f prime of 4 will have a slope of 8. So when I come over to 4, this thing has a slope of 8. It's increasing right then, going up by 8 over 1 at that minute, at that second, at that instantaneous spot. If it's like 4.01, then clearly it's going to be a skosh more, yes? 8.02, it's always going to be increasing on that side, yes? Obviously on this side, you put in negative x's, you're going to get negatives out. What happens at 0? What's the slope at 0? It's 0. Wait a minute. I have a question. In Algebra 2, what did you call this spot? Not a vertex, by the way. What did you call it? A minimum. Wait a minute. If you have a minimum, won't you always have a horizontal tangent line? Yeah. Would that be the same thing if you have a vertical? I mean a maximum? Yes, it will. And so when we start doing max and minimums, we're not going to be this whole graph, this side, that, or Desmos, click. No, we're going to use a calculus to do these things because it's kind of a big deal. Okay, now we're going to do some more. They are not very hard. Really, it boils down to today a lot of algebra. But you're going to have to be able to explain that picture to me that I drew, the very first picture. You're going to have to be able to understand in your head, why is it that the square root of x, for instance, is not differentiable? Because it doesn't have a limit from both sides, for instance. Why is it when you see a point, it's not differentiable? Because this is negative slopes and these are positive, and it's not the same limit. Things like that are a big deal. But it will help us, because when we see those limit laws, you're like, well, duh. Well, duh. Or derivative laws. Well, duh, it's a freaking limit. All right? Now, Hallie, this one is for you. All for you, because, well, I feel like helping you out. What? Oh, by the way, what is the derivative of a constant? How fast does a constant change? It doesn't. So, interestingly enough, if I said to you, here's a horizontal line, how fast is it going up or down? You go, it's not. And you'd be right. Good job. Now, here is F. Do you have a question, Levi?
Huh?
Do you have a question? Let you start to raise your hand. Was I wrong? Was it not? It's fairly straightforward, is it not?
That's pretty sweet.
Okay, thank you.
I got some weird values for the constants.
I am not good. Listen, I take no responsibilities for the constants. I said the eigenvalues would be nice.
They are pretty nice. Yeah.
Thank you. You're welcome. All right. Now, I didn't try to make the eigenvectors nice. I don't care. Now, here we go. Obviously, I need this. The recipe says I need this. Yes? So, what's it going to be? Well, this is going to be what it was a second ago, right? Because the x squared part will be the same, well, always. Plus 6, x plus h, minus 8. Okay. So let's distribute this mess out. So 2x squared plus 4xh plus 2h squared plus 6x plus 6h minus 8. Ooh, that sounds fun. You make some funny noises when you're thinking.
I love math. I'm learning.
Isn't that kind of fun? Yeah. So, okay, here it is, people. So I need this fella here, this first guy, 2x squared plus 4xh plus 2h squared plus 6x plus 6h minus 8 minus, and this is where the rookies will screw it up, minus the entire original function. The rookies amongst us will only change the sign on the 2x squared. And that will be an issue. Okay? Again, when I point out those rookie mistakes, I don't think it's just for the rooks, because I haven't done that in years, but I used to do that all the time. All the time. So, I'm going to go ahead and write it out nice and slow and skip no stepperoonies. Remember, all I'm doing is rewriting it. It's no big deal. Minus 8, minus 2x squared, minus 6x, minus 8, all over h, yes? Now, I said to you the original function would cancel out, yes? Hey, 2x squared, 2x squared. Hey, here's 6x. They're gone. Hey, there's my 8s. Oops. This was...
The original was negative.
God dang it. The original was negative. There, now it's positive. I told you if it doesn't go away, you screwed up. That's a good check. The 8 had to cancel. I probably would have just canceled them anyways because I just know they're supposed to. But yeah, if they don't, go back and check. What do you get?
Did I use the matrix right? Because I have 6, 8 plus
The matrix.
Then we did this. Did I?
Well, I feel like. What is our thing? What's our eigenvector? 7?
Mm-hmm.
Negative 7.
Negative 7.
Well. Okay, listen, all I know is that go do it the other way. Treat that as a separable first. Solve this, and then you get a linear. Okay, solve that first down here, and then you'll see it happen. I don't know. You're missing something, but I can't see it right off the top of my head. Okay, something's a little screwy. I swear it works though. Okay, now. So what's left on top? Well, I'll tell you what's left. Everything but the original. But hang on, can I just say something? Can I just say something for a second, please? Remember, this is just kind of for what it's worth, friends. Remember, this is the slope function, yes? So whatever's on top is the change in y. So if I said to you, look, I went over 1 unit, like let's say I started at x equals 2, and I went over 1 unit on the h, you plug that in, you could tell me how far you went up, see? That's still there, because it is still the slope formula. When you subtract, it's whatever's left over is what the change is. You started here, you went up to here, subtract, this is the difference on top, yes? Obviously it matters where you are on the x-axis, and it matters how far you went over h, yes? That's if you wanted macro differences. Now, let's keep going. What do you notice here? The h's cancel, and you're left with 4x plus 2h plus 6. Oops. And what is the limit as h goes to 0 of this mess? Why, it's 4x plus 6. What's up?
So on this one, am I just trying to do math?
Well, I feel like you know this.
Yeah.
So you can plug it into this.
Yep.
And does this look like, do these guys look like those guys? Ooh,
See,
almost.
this is
What's up?
the matrix that I was
The
confused.
matrix, yes.
Because it could be anything.
That's right.
But then if I change,
Hang on, hold up. You're freaking me out, man. You're freaking me out, man. And where's the other one at? Where's your other matrix at? This one here? Yeah.
yes, that one's going to apply. It's only that one right there. It should be one.
Yeah, double check it. I haven't done that.
Okay.
I can't see it off the top of my head, but everything's right there. You just got to finish it. All right. Shh. Time out. Now, is that working for you guys? That Angel, is that good for you? You see where I'm at? Okay. So, I'm going to go to the Desmos real quick. And I want to graph the original function, which was what? X squared plus, no, 2x squared? Freaking hate this thing. They've screwed with my thing so much it doesn't even connect by itself all the time anymore. And it's your people's fault. I know the guest password. Oh, it's great. Guess what happens when you clowns log in? Apparently, it takes mine, which should have full-on priority, and pushes me off to some part of the building. So now it takes forever to upload anything. It's crazy. I was like the other day, I'm like, they're like,
why are you on the guest?
I'm not. That's the thing. I said, what difference does that make? They're like, is it plus 6x?
Yeah.
And they said, it doesn't matter, Jay. You're on the same WAP. And I went, what? It's the same wireless blah, 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 blah. But when there's all this crap on the guest and the others and the lion nets and the Leo nets, the extra traffic pushes you off to a different WAP. And I went, well, that is the stupidest thing I've ever heard of. Anyway, apparently it does. I don't really care. I just know that's how it works. Plus 8, minus 8. Okay, so there's my function right here, yes? Nice. Now, I am going to plug in, for instance, let's do this guy right here. You see this? 0, negative 8. You see this? See that? That's nice, huh? Nice. So, screen, why are you doing that? Here's what I want to do. I would like to find the equation of the tangent line, but you can just pretend like it's just a line, through 0, -8. Well, that means I need y equals mx plus b, correct? How in the devil am I going to find my m? I feel like this is your slope equation, isn't it? And what x value am I interested in? 0. So if you plug 0 into this mesh, you get f prime of 0 is 6. This is your slope. Yes? And so y equals, well, what are you doing y equals, you dummy? -8 stop it. -8 equals 6 times 0 plus b, so surprise, surprise, b is -8. That's nice. So then my equation is simply y equals 6x minus 8. This guy right here will be tangent to that graph. Now, is it 6x? Oh, look how many times it touches the graph, yo. Just the one time. As if it was, I don't know, a tangent or something. Nice. Yes? Now, Hannah, here's a question for you, because why not? Yeah, so f prime of x, which of course is the slope, is equal to, what do we say? 6x minus 8? No. 4x plus 6, thank you. So Hannah, here's my question. Where does the slope equal 0? Well, no. But no. Where does the slope equal 0? I don't know. But this is child's play to solve, yes? It occurs at x equals -3/2, correct? Yeah? What the heck is going on at -3/2, yo? At -3/2, what do we have? Why do we have a 0 slope? It's as if it was a minimum there. That's exactly correct. Exactly. And then we will continue to see this as we go along. Now, a couple that are a little trickier because that's what we do. We start small and we build up. Square root of x. You said we can't. Just a cotton picking minute. I know what I said. I said it doesn't exist at 0. I didn't say it didn't exist everywhere, for gosh sakes. I just said it didn't exist at 0. So, I would, of course, need to find f of x plus h. Would I not? And what would it be? I know. Yeah. And so it's the limit as h goes to 0 of this fella minus this dude over that guy. Or lady, whichever the case may be. Oh, by the way, please go on my St. Helens webpage, on the stats page, take the survey. Please take it somewhat seriously. I am trying to gather some data for my stats classes that I teach. What? Okay.
Yeah.
Anyway, please try to take that a little bit seriously when you take it, okay? Anyway, I just need it. But anyway, just take it before the end of the weekend, so I can get it done. What?
Don't say it twice.
No, just once is fine, bro. Just once.
You can't take it twice on screw through the
It would screw up my data. Now, listen. Nothing is going to cancel out here. I need to get rid of these stupid square roots. You cannot square it. Please don't suggest that. But what I can do is I can multiply it by its conjugate. This is a trick, and again, we show you the tricks to get into the clubhouse. There it is, the secret handshakes and whatnot. It is a trick. Without this trick, you are screwed on this problem. But with it, what do you get? You get this times this. What is the square root of x plus h times the square root of x plus h? It's x plus h. Duh. There is no middle term because they're conjugates. They cancel out. And then, of course, I get minus x. Square root of x times square root of x. On the bottom, of course, you get this. Now you could distribute it out, but please don't. There's a reason we don't do it. I will show it to you momentarily. Yes? What do you notice on top? The x's cancel. And then what do you notice? What do you notice? The h's cancel. Of course, that leaves us a 1 on the top, yes? Now, what is the limit as h goes to 0? Don't tell me it can't go to 0. It totally can. What happens when you get down there? Well, you get the square root of x plus the square root of x, don't you? And how many square roots of x's is that? That's 2 of them. So this guy right here, you see, is f prime of x. It is the slope.
Question.
Yes?
What happened to the square root of h?
Yeah.
Where are you talking about square root of h?
Because when you cancel out the 2 h's, there's still an h, square root of x plus h.
You're taking the limit as h goes to 0.
Oh.
Bye-bye. Now, Lace, I have a question for you. I'll be right there. Lace, question. I feel like a few minutes ago I drew the square root function like so, yes? Whee! Yes? And I said, look, at 0 we had a problem. Yes? Yo, check out its derivative. Where does that sucker have a problem? Among other places, 0. Ah? That's pretty cool. Huh? That will continue to happen throughout. Okay? Now, Lil. Okay, now. Okay, I'm going to pause for 2 seconds. Talk amongst yourselves quietly here. And the next one we're going to do is sine of x. Now, we're going to do it with the limit definition, or at least we're going to die trying. Okay? So, 1 moment, please. Yeah.
I'm saying it like really.
Isn't it cool?
Yeah.
Isn't that cool?
Isn't that?
Everything just comes
The guy who Listen, 0a plus 0b. What can you put in? It doesn't matter what a and well, if anyone would make this work, we'll make it all work, sure. Because your time's yeah, don't get fooled by sweaters.
Oh, you taught me my Oh, okay. Legally, you have to count. I shot.
Anything.
I hated on us.
What?
Oh,
and then you get y equals something, yes? Yeah. And then couldn't you plug that in for y? You can do it. You can do it. I don't know. We'll see. Shh. All right. Now, what would this be? It would be the sine of x plus h, obviously. Wait a minute. Mr. Groom, last year, Mr. Patterson made us learn the angle addition formulas. Or Mr. whoever. Okay, they don't either, so don't feel bad. Okay? They didn't even remember who their teacher was last year, so don't you feel bad. Now listen, sine of alpha plus beta is equal to, remember it's the sine of alpha, sine of beta, plus, oops, I'm sorry, I lied to you. Don't hate me. Cosine of beta, whew, got it. Cosine of alpha, whew, sine of beta. Found it. Whew, whew, I got it. What's that? Dude, sine is the same sandwich. Look, it's the same sandwich. So you squeeze them in there, yo. Nice. And then Mr. Ford says, you taught us it was a sine which. And I went, I don't remember that, but that does sound something like I would say. It's a sine which. Yes, I don't know. Anyway. So, if it was the sine of x plus h, then it would be equal to the sine of x times the cosine of h, right? Plus the cosine of x times the sine of h. Bless you. Yes? Yes? Nice. Now, let's do the limit as h goes to a goose egg. So I need to have this feller, this guy, plus this dude, this guy, minus this guy, over h. As at this point, if this was a movie, you'd be thinking, how will Rocky ever get off the mat? You are thinking, how is Billy the Kid going to escape this shootout this time? You are going to be thinking, how are Butch and Sundance going to live? Right? You are thinking, how are they going to come back? And then Babe steps up and calls his shot. This is what you're thinking. Now, friends, at this point, we realize that we learned the limit laws. And the limit says this: the sum of the limits is the limit of the sum, and vice versa. So I could rewrite this as 3 separate limits, and by the way, for a reason, or just 2. I'm going to go with 2, and you're going to see why momentarily, but follow me, okay? I am going to do the limit as h goes to 0 of the, I'm going to do this one,
I hate my life.
oh, shut up. I'm going to record that. Can you say it again so I can play that back to you one of these days? When you're hyperventilating on a test?
That's what I'm saying.
Yeah. It is funny. Karma's a funny thing, isn't it? Yeah. Okay. So you follow me here, right? Now you're not sure why I broke it up there. I know, because I know where the end of the story goes, okay? But I could have broken it into 3 separate pieces if I wanted to. I want just these 2, though, okay? Now, hey, see, I'm going to attack this one here, if you don't mind, for a moment. May I? Is this okay with you, dear? Now, we know that that is a product, yes? And I could have written it thusly then. So I'm going to leave this. I'm going to leave this piece alone for a minute. I'm just going to work on just this side right now. I could have written this as the limit as h approaches 0 of the cosine of x times the limit as h goes to 0 of the sine of h over h. Wait a minute. Sine of h over h, didn't we look at that one the other day? I think we did. What is it? You should probably look in your notes. The limit as h goes to 0. Yes! It is 1, by God. That's true. I'm proud of you. Now listen. What is the limit of the cosine of x as h goes to 0? This is tantamount to asking me this. Knowing that my mom is in the hospital today, which she's not, but if she were, what is the chance that you get in a traffic accident? What? Exactly. What is the limit of the cosine of x as h? Who cares what h is doing? What is this going to be? It's going to simply be cosine of x. This is a big freaking deal. That is something that you should mark down in your memory banks somewhere. The limit of a constant is, well, the limit of a constant is 0, and the limit as like h goes to 0 of some other variable is whatever the other variable is doing, because it doesn't care what h is doing. Okay? So if I ask you what x is doing as h does this, you're like, what? What? That makes no sense. So just leave it cosine of x. Now notice we still have a plus over here. So plus. Now let's go look at this fellow over here for a minute. Friends, what happens to the numerator? Because we know we can use our limit laws again. At least I don't think Mom's in the hospital. I ain't even got a call from her, so that would be pretty weird. Wouldn't that be creepy? You get home, hey, I'm in the hospital. Oh, awesome. Great. Nope. Shh. Now look, I can do what I just did because we were told that's possible, yes? We can distribute it through. I want to focus on just this piece right here for right now. What happens to the cosine of h as h goes to 0? What is the cosine of 0? You're close. You went, no, it's 1. This thing right here is 1. This piece right here is 1. Well, that's cool, because what do you get on top now, friends? You get the sine of x minus the sine of x. Hey, that's cool, over h. Now, I'm going to bring this back outside for just a moment. What is the sine of x minus the sine of x? Well, I believe it's 0. So all this side really just goes to what? 0 plus, and then of course cosine of x times 1 is cosine of x. And so the derivative of sine of x is simply cosine of x. Did you get it?
Yeah.
Or did you punt?
No, I got it.
All right.
I don't punt. I go for it on 4th down.
All right, Mike Leach, I like to hear it. This is good. Now, allow me to draw, if you will, allow me to draw the sine function with my purple crayon, if you will. Our sine of x. Question. What is the slope right here? What is the slope of sine right there? 0. What is the slope of sine of x right here? 0. What's the slope right here? What? 0. And I could do it one more time, but I'm bored of it already. I think we're good. So here's my question to you. Between here and here, is the function increasing or decreasing? This function from here up to here, is it going up or down? It's going up, so it will have positive slopes, correct? So watch me show that. What? Now between here and here, the function is going down, so we'll have negatives. Dude! What is this function here? This feller. It's cosine. That's pretty sweet. We will do more with this later on. We can do the same thing with cosine. Matter of fact, let's do it now. While you do it, while I walk around and make you feel uncomfortable. Please remember that the cosine of A plus B is equal to the cosine of A, cosine of B, minus sine A, sine B. Try that using that formula. Whilst I go and help these people.
That's a mistake. I just think you're like, it's called that messed up. I decided I want to do
Alright, go, come on, let's go. Oh, is that why? Well, let's take it right there. dx of t equals negative x plus 2 e to the negative t is equal to dx to t. And then solve that. We know how to solve that. That's a special kind of problem.
Linear?
Yeah.
Cool.
No? Am I trying too hard? I like this. Everybody knew they were done the same way.
Are you doing something out of your
How are you possibly?
You're doing it for cosine X.
I got you now. So listen, I need to have, I cannot write my book on this. I need to have this. So I'm going to have.
Those are your I was sitting there, and I was like, I'm pretty sure about parts.
Rewrite this A and B.
I promise. You can't do it because there's an X and a T. What? You can live with what? No, I was talking about I didn't realize it was left for
Shut up. You really didn't notice.
Yeah, I don't know. Okay. But
Did they?
Okay, yeah.
That's good.
Until we were done.
Okay, so listen to that. Yeah, right. Exactly. Just like that.
I'm trying to prove that it works.
Oh my word. I keep trying my hardest and never looked at it. Just rewrite this right here. Just like minus cosine x. Yeah, my original equation was cosine x. I said cosine right now.
I didn't have to want to vote.
Yeah.
Oh, I get it.
Is that what you said?
Yeah, that's fair.
All over it. So yeah, you were doing what? Last time, yes, I compared the last one. Compared at the same time. Because I want to get the science to do it. What now? Compare this guy and this guy. Try with that. Oh, don't my head. That's the circle. You just kill the chips in. That's going to be your next thing. Yeah, this is all over. All over 80, right? This is the morning one. Take a step. Hold on a second. This guy and this guy equal yes! Listen, did you say that? Did you say negative sign? You're amazing. Okay, listen. Shh. So, let's start trying it out here. Most of you have gotten to here. I hope you've gotten that far. Most of you have gotten this, though. You've gotten this, and this, and this, and this. Ah, not A, you stupid. Right? Now, last time we paired the two with sine x's together, yes? This time I'm going to pair the two with cosine x's together. So I'm going to break them into two pieces. Again, because I can. Because I can. So I'm taking this first guy. Right? Plus, or yeah, I'm going to say plus for right now. You'll see in a minute. It's okay either way. Right? Yes? You're looking familiar now, isn't it? Hey, look, it's sine h over h again. What is that guy? 1 times what? Well, what is the limit of negative sine of x as h goes to 0? It's just negative sine x. Right? Plus, now what's happening over here? Well, I don't know. But on top, if you let h go to 0, this piece goes to 0. And cosine minus cosine is
0
over h, which is 0. So the derivative of cosine is negative sine. Yes, yes, you will have to memorize those. But they happen the same way every single stinking time. Now, this is for Jacob Olson because, well, Jacob never talks, so I'm going to pick on him. Jacob, question for you. I'm just teasing it. But here's the deal. What if I had f of x was 6x, or 6 cosine x? What would the derivative be? Yes! But why? Because it's a limit. And what can you do with constants when you have a limit? Just pull them out front, take the limit, and then times back by that constant when you're finished. Yes? Yeah. That's the beautiful thing about it. So you don't have to memorize 87,000 things. Geez, I got cosine. Cosine's going to minus sine. What about the constant? Bro, it just comes along for the ride. It's fine. Okay? Now, I want to do this one last one. But listen, I'm going to ease it up for you, and you're going to say, oh, it's so hard. It's not hard. It's not hard. I promise. Now, at first you're going to say, oh, it's so gross. It's not. I promise. 4x squared plus 2 plus the square root of 3x. Okay, stop. Haven't we done the derivative of x squared already? Yes? So if I have a 4 in front of it, it's going to be 4 times whatever it was a few minutes ago, yes? How fast does a constant change? It doesn't. So the derivative of this piece will be? We did square root of x earlier. Interesting. So let's look at this for a minute, please. So let's look at this. You could have done 4 times the limit as, oops, not h goes to 0, you idiot, of this guy. Well, I'll just do this. Well, I'll do f of x. Well, how will I do it? X plus, I'll write it like this. I won't actually write it out. How about that, okay? We already know this bit here is 2x, don't we? Right? That's what we already did on the first problem. We did that, yes? We knew it was 2x. So our answer is going to be 4 times 2. This piece will be 8x. Yeah? How are you able to do it in pieces, Mr. Groom? Because we're doing a limit. And the limit of the sum of the limits. You want to do it in one piece? Good. Do it in a zillion pieces. That's fine. Whatever's easier for you. Here, quickly now. If f of x was equal to 2, what would f of x plus h be? Two. And so the limit as h goes to 0 of, I don't know, 2 minus 2 over h, that's, that's 0 over h. This is 0. What is the limit of 0? I feel like it's 0. It's not. It's already 0 over a value that is not 0, although it's going towards 0. But it's already 0, bruh. It's 0. Remember, if you have no pi at home, there is 0 pi at home. No matter how many people you invite over, you ain't got no pi. Now, so this is plus 0 in the middle, obviously. Now, look at this deal right there. Look at it. Square root of 3x. Can I write that differently? I think I could write it as the square root of 3 times the square root of x. Well, we already found the derivative for this fella, didn't we? And what was it? It was 1 over 2 square root of x. So it's just going to be times by the square root of 3. So our final answer will be 8x plus the square root of 3 over 2 square root of x, whatever that is. Okay? What you're going to see is the rules for limits will help you immensely. Now, on the homework tonight for this section, which is 2.7, but don't quote me on that, the limits definitions, it's 2.7 or 8, whatever. I know you're going to say whatever I said it's wrong, but whatever. So when you work on these tonight, I don't want to hear because I have a volleyball game. I have the Mr. Grimm. I have to go on my horse. Mr. Grimm. I want you to go home and try them tonight, so that when you come tomorrow, you can have. I'm stuck. I am just stuck, and then I can hopefully give you a few pointers and helps. And I'll probably have a small video for you, like, but it's our work day. I know, with a few more examples. Okay, so that you can hopefully see some more examples. I will kid you not, there's a lot of algebra on this thing, but they all work the same way. You may not believe it. I didn't believe it either back in the day. I always thought that there was a trick to this one. Not really. They all work the same way. Okay? So you're going to try them. Please expect to work hard and a few of them to kick your butt. Because that's what's supposed to happen. Okay? If you're not getting your butt kicked from time to time, you're not being challenged enough.